Today we're going to be solving Leetcode Problem 1762, Buildings with an Ocean View. Currently, this problem is really popular with Facebook, Amazon, and Microsoft, so this is definitely one to know for your upcoming on-site interviews. Alright, let's read the prompt and jump right in. There are n buildings in a line. You are given an integer array heights of size n that represents the heights of the buildings in a line. The ocean is to the right of the buildings. A building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have a smaller height. Return a list of indices, 0 indexed, of buildings that have an ocean view sorted in increasing order. So for example, if we were given this input of heights, 4, 2, 3, 1, which we can see here in the diagram, we would expect to return 0, 2, and 3, because these are the buildings with an ocean height. But let's see how we might actually derive this. Well, if we look at this building 1 here, we see that it always will have an ocean view because it's right next to the ocean. That's cool. Okay, so we get to the 3. This one has an ocean view. Why? Because it's taller than all the buildings to its right. So clearly this one has an ocean view. So that means that this is an answer, this is an answer. But now we get to this 2. This 2 obviously doesn't have an ocean view because its height is blocked by this 3. So that means that this 2 here does not have an ocean view. And this 4 does have an ocean view because it can see over all the other buildings, meaning it can see the ocean. So that's our result. And as we can see, this matches up with what we expect because the indices corresponding to 4, 3, and 1 is 0, 2, and 3, which is what we expect out of the answer. So conceptually, the way that we want to solve this is actually we're going to start here at the right and we're going to track the largest height that we've seen so far. And we'll initialize our initial max height to -1. And what we're going to do is we're going to iterate from right to left, and we're going to compute whether or not the current height is actually greater than the maximum that we've seen so far. If it is, that means that that building has an ocean view, and we can append it to our answer. And since it's greater, we're actually going to update our height. So for example, starting from the left, we'd see, okay, is 1 greater than -1? Yes, it is. So that means our max height is now 1. And we would add that to our result array, right? Cool. Then we're at this 3, and we see, okay, is 3 greater than our max height? Yes, it is. That means we have a new ocean view. And then we can add this index. Apologies, this should actually be 3 here because we're adding the indices, not the values. And then we're going to add 2 here. And then we're going to move on. So is 2 greater than our maximum, which is 3? No, it's not. That means that this does not have an ocean view, and we simply continue. Then we're going to go to this 4 here, and we're going to see, okay, is 4 greater than the maximum we have so far? Yes, it is. So we can update our new maximum, which is 4, and we can say, okay, what index does this occur at? 0. And at this point, we're actually done because our array is over. And what we need to do now is actually just reverse this. Since we went from left to right, we just need to go, we went from right to left, so we need to reverse it so that our answers are left to right, because you can see that the problem asks for sorted in increasing order. So we want to make sure that we actually reverse it. What we could do is actually use a deck here instead of a list to avoid reversing that, but that's a little bit of a micro optimization. Cool. So let's actually put this into code and see what it would look like. Actually code it out and make sure that our solution is going to work. The first thing that we're going to want to do is actually make sure that our heights array isn't empty. If it is, then there's nothing for us to process, so we don't actually need to do anything. So let's check that first. We're going to say if not heights, we're just going to return an empty list. Cool. So now we actually need to do the processing. So let's declare the variables that we're going to need for this. If you remember from the drawings, we were keeping track of the maximum height we've seen so far. So let's declare that and initialize it to -1. And we need a container to basically store our result indices. So let's say res equals collections.deck. Cool. And the reason that I'm using a deck here is because we're appending each time. And remember that at the end, we had to reverse our array. And using a deck, I can actually append to the left of the array in constant time, which will actually save me the need to reverse my array in the end. So just, a little bit of a micro optimization. You don't have to do this. I just like to. Cool. So we need to go from right to left. So let's set up that for loop. For I in range, len heights, -1, -1, -1. we're going to say that the current height is going to be equal to heights of I. And we're going to say, okay, cool. If the current height is greater than the max height, that means that the current building that we're at has an ocean view. So we need to append to our result. So we're going to say res.append left. We're going to put the index in there because that's what the answer is looking for, the indices. And we're going to update our maximum height. So maximum height is going to be equal to the current height. And that's really it. This is quite a simple problem. All we need to do now is just return res. So we'll go through our array from right to left, and we'll do this at every single step as we saw in the diagram. And all we need to do now is actually just return the res. So let's do that and verify that our solution works. And it does. Excellent. So now that we know that our solution works, let's actually go over the time and space complexity here, because this is an important part of any algorithms question. So what is the time complexity? Well, we know that we have to traverse every single element in our heights array. And each time what we're going to do is we're going to do a constant time comparison against the max and potentially update the height here, which is all just O of 1 operations. So realistically, our time complexity is going to be big O of n. And space complexity. Well, in the worst case, every single building in our array is actually going to have an ocean view, which means that we're going to have to store the index of every single of every single building in our result, which means that it's going to be big O of n, because in that case we would have to store everything. So that's going to be our solution. Quite a simple problem, relatively straightforward, and I hope you enjoyed. If you did, please like, comment, subscribe, and stay tuned for more videos.